Hi everyone, we are Team Ensemble and we are here today to show you about how we can harness energy from industrial HVAC ducts, exhausts and Duton-driven water pipelines. There are hundreds of ducts and channels across the manufacturing units and process chain corporate buildings. The modern infrastructure is designed based on the airflow direction, gravitational pull and reduced spaces. Firstly, let's look at the evolution of wind turbines. We have come a long way from the custom windmills through the water mills driven via the wind and the modern wind farms with modern facilities. In recent times, we have experienced a shift from the horizontal axis wind turbines to the vertical axis wind turbines, namely Darius wind turbines rotating on the vertical shaft, the Gorlov helical wind turbines, and the fluid-driven wind or water hybrid spherical turbines. Today, we see the wind farms having HAWT and VAWT simultaneously. Coming to HVAC system, our idea aims at harnessing the HVAC condensing fan exhaust using the hybrid Gorlov helical and Darius wind turbines. A single set consists of the turbine generator set, where output powers can be stored in the rechargeable batteries. For instance, consider a corporate building functioning for 10 hours a day. The HVAC system works continuously for 10 hours and produces heat exhausts from the condensing fans at a velocity of approximately 5 to 15 meters per second. A single unit of 1 meter diameter, VAWT, can produce up to 500 watts of power. Since there are many HVAC units in the industries and buildings, we can surely give a thought to an exhaust farm. Our idea can be customized for the factories or buildings having the air handling units in HVAC arrangement. The fixed airspeed passes through the handlers and vents ensure the possibility of constant energy generation during the factory or corporate working hours, regardless of wind speed and direction. These type of turbines also find usage in the energy generation via the gravity-driven water pipelines coming out of the water treatment plants. Consider a portion of the duct or pipeline. Based on our study, we have decided to make use of the Gorlov helical turbine to harness the energy. This turbine generator set can be installed based on the type of the project. Since the diameter of the ducts vary from 30 inches to 100 inches, we can easily customize the set, which consists of the squirrel cage induction generator. The Gorlov helical turbine is highly efficient and provides least hindrance to the airflow or water flow. The fluid passes through the turbine, rotating the helical blades that can be converted into electricity with the help of squirrel cage induction generator. Since there is a continuous flow of medium via the cross-section, there can be arrangement to harness the electricity generated for lighting and fan load. Industries and factories make use of electricity from the grid. By implementing our idea, we can reduce the overall cost of electricity along with the load on the grid. Alternatively, we can feed back the energy to the grid through the use of compensators. Here are some of the market overview and real-time usage of these turbines. So first up, street lights in Seoul, Korea. These street lights are driven by the hybrid setup of wind energy and solar energy. Secondly, Jungborgo Resort Station in Antarctica. These turbines operate at minimal wind speeds as well. Finally, the World Expo 2010 in Shanghai. So the biggest question which is yet to be answered, how effective would the idea be? The idea of bringing a wind energy system into urban areas is more challenging because of limited available space and reduced wind speed because of infrastructure and building geometry. Thus, an efficient method would be able to generate clean energy from the man-made wind such as heat sink, exhaust air, etc. We can make the lighting and fan load and other miscellaneous electricity consumption independent of the grid energy with implementation of our idea alongside alternative methods such as solar energy. By doing so, we are vicariously reducing the carbon footprint on the Mother Earth. Alternatively, we can call it as an indirect reduction of carbon footprint via compensation technique. So thank you all from Team Ensemble.